All right, guys, welcome to Unit 3.2. The nice thing about me being gone for 2 days is today is just basically review, so it's stuff that you already know how to do. So this won't take very long, and you'll have some time to work on your stuff. We want to combine differentiation and integration today just to make sure you can think in the right order. So this is just straight review. So get your notes out and follow along with me. If you need to pause the video, go ahead and do so. Hopefully this shouldn't take too long. So the first example here, it says find the derivative. Do not leave negative exponents or complex fractions in your answers. So hopefully this is pretty easy for y'all. The derivative of 3x to the fourth would be 12x cubed. The derivative of 2 over x, I would write that or think of it as 2x to the negative 1. So my derivative would be negative 2x to the negative 2. So I'm going to write that as negative 2 over squared. The derivative of negative 12x to the 3/4 would be negative, let's see, that's going to be 36 over 4. So that's going to be negative 9. X to the 3/4 minus 1, which is 4/4, would be negative 1/4. And the derivative of e squared, once again, is still 0 because that is a constant and it doesn't have a variable. So negative exponents, I got to get rid of it. The x to the negative 1/4 means the 4th root of x on the bottom. So I'm going to write it like that. And there's my answer. Okay. The second example is just a chain rule problem. I really moved the cube out to the outside, so I remember that to do that. That's really the outside. So I'm going to rewrite it as sine of 5x to the 4th. And that's, of course, raised to the 3rd power. So the derivative of the outside has got 3 layers. And so the derivative of the outside would be 3 times the sine of 5x to the 4th. Don't touch the baby. Squared. Times the derivative sine would be cosine. Again, don't touch the inside. And then finally we multiply by the derivative of the inside, which would be 20x cubed. And then I'm just going to make it look pretty. So 3 times 20 is 60. X cubed times the sine squared of 5x to the 4th times the cosine of 5x to the 4th. And that would be my derivative. So hopefully that's fine. If you need to pause the video here to catch up with your notes, go ahead and pause the video. When everybody's ready, we'll move to the next slide. Okay, when you take the ln, remember the derivative is 1 over x, and you have the ln as stuff, as we heard in the, what would the derivative be? It's 1 over stuff times the derivative of stuff, all right? So the ln, the derivative is 1 over the stuff in the inside, which is x to the 5th, plus 2x cubed, times the derivative of the inside, so that's just going to go on top. That would be 5x to the 4th plus 6x squared, and we are finished. Okay, now the next example is e to the x. So remember, it's e to the stuff times the derivative of stuff. I really like that. All right, anyways, the derivative of e to the 5x squared is e to the 5x squared, so you just repeat itself, times the derivative of 5x squared, which is 10x. And here's our derivative. Log base 3 is one that we just learned, and so all you really have to do is multiply by the ln of 3 when we're dealing with other bases besides e. In calculus, we like e because you don't have to have all these ln's running around, but we didn't do that. And with a log, you want to make it easier because you want to split a product into a sum. Use your log rules to help you take derivatives. And so So we talked about that. So what I'm going to do is split this apart first. I'm going to write it as log base 3 of the square root of 2x minus 1 plus log base 3 of x cubed. And we know that powers can come in front a lot, so you want to do that too because that'll make life easier on you. So the square root is like raising it to the 1/2. So I'm going to put a 1/2 out front. So it's 1/2 log base 3 of 2x minus 1. And we're going to raise the 3 from the x cubed here, put it out front. So it's 3 log base 3 of x. Now I have something I would rather take the derivative of. So remember with the log, it's going to be 1 over, but you need a factor of ln 3 to take care of the base. So what you're going to have is 1 over 2x minus 1 times the derivative of the inside. I have a 1/2 there, all right, but times through the inside, which would be 2. And I'm going to multiply this by the ln of 3 to take care of the base because it is not base e. Same thing here, 3. The derivative of log base 3 of x would be 1 over x times the ln of 3 because, again, base is an e. All right, so just a little bit of math here. Cancel the 2, so I get the ln of 3 over 2x minus 1 plus 3 times the ln of 3 over x, and that's my derivative. I can stop there, and we're happy. So again, this is just review. It's nothing new. It's just to kind of put it all together in one piece with all the rules we've learned. Everybody good? Again, you can stop the video here if you need to get caught up. I'm going to keep going, but go ahead and stop it if you need to. All right, so integration, now we're just going in the opposite. We're going to raise it a power and divide by it. So the integral of 3x squared is simply x cubed because the 3's cancel, and then the integral of 5x would be 5/2 x squared, and the integral of 4 would be 4x. And of course, we're not going to forget our constant because it's an indefinite integral. You need to plus c. So this would be the integral of that. Okay, hopefully no news. All right, this next example is one in which we need to use substitution because I don't want to multiply that out 4 times. So remember, u is the thing on the inside of the parentheses. So u would be, all right, 2x cubed plus 5. All right, du would be 6x squared dx. So when I compare that with my integral, I am missing the 6 from the 6x squared. So I'm going to need to put it inside my integral, which means I put a 1/6 on the front. So now I rewrite this in terms of u. It would be 1/6, the integral of, let's see what we got here, u to the 4th times du. Now we integrate. So the integral of u to the 4th is 1/5 u to the 5th. So I am going to get 1 over 6 times 5 is 30th u to the 5th. But u is not u. U is 2x cubed plus 5. So I get 1 over 30 times 2x cubed plus 5 raised to the 5th power plus, of course, c. Okay? So again, nothing new here, just reviewing integration by substitution. You're going to see that a lot this year. We be able to do it because we're going to start throwing in some funky integrals. But today is just straight review. All right, this next one would be substitution. What am I going to let my u be? Of course, it's going to be the thing on the inside. So u is x cubed. So du would be 3x squared dx. So I'm missing a 3, so I need a 1/3 out front. So I'm going to put a 3 in there and a 1/3. So what I have is 1/3 sine u du. And let's see, the integral sine, let's see, derivative cosines, negative sine, so it's going to be negative cosine. Of course, u isn't u, but u is x third, so it's negative 1/3 cosine of x cubed plus c. So nothing new today, just reviews of things that you already know how to do. If you need to fast forward or stop, feel free to, because you know all this stuff. All right, the integral of e to the 5x, one really helpful hint with this, you're starting to see that I just divide by a number with ease and the trig. If I let u be 5x, so du would be 5 dx, so I need to put a 1/5 out front, 5 in there, so what I have is 1/5 the integral of e to the u du, which is really easy because the integral of e to the u is e to the u, so it's 1/5 e to the u. But of course, u is just 5x. All right, let's see. One of the easier tricks I know is the integral of e to the ax. If a is a constant, it's always going to be 1 over a in the ax. A helpful trick to know. We're doing that integral a bit. So, and it's the same with sines and cosines. If you have like the, whatever, the sine of 2x, and I want to integrate that, it's just 1 over 2. Divide by that number and then integrate. So, see if you're cosines of that be negative. But you still just divide by that number. That's true with trig, it's true with exponentials. This is just a definite integral. If it's okay with y'all, I'm probably going to skip that. Just change your limits. I think you know how to do that. We'll do one of these. I don't think I need to do all of them. Ooh, 2 to the 3x minus 1. All right. So by now, you should know that the integral of a to the x would be a to the x divided by the ln of a. It's just like e to the x. It's just that we integrate instead of multiplying, you divide. So you just divide by the ln of the base. So with an integral like this, I'm going to let u be 3x minus 1. So du would be 3 dx. So I need a 3 in there. So I need a 1/3 out front. So what I have now is 1/3. The integral of 2 to the u times du. And the integral of 2 to the u is 2 to the u over ln 2 because of that different base. So it'd be 1 over 3 ln 2 times 2 to the u. But u is, of course, 2 to the, what's u called, 3x minus 1 plus, okay? So anytime you have a base, it's not e, you just have a factor of ln of the base. If it's a derivative, you're going to be multiplying. If it's an integral, you're going to be dividing. Okay, this looks straight scary. Not really, but if you don't know, it's got to be some kind of substitution. When I have a fraction, I'm going to try u as the bottom first to see if I can maybe work that out. So u, if I let it be 1 minus 2 to the x, du is negative 2 to the x times the ln of 2 dx. And if you see that, you can see that I've got my du, I just need a negative ln 2. So I'm going to multiply on the inside by negative ln 2, which means on the outside I'm going to divide by negative ln 2. So now what I have is the integral of negative 1 over ln 2 times 1 over u, which is somewhat interesting. The integral of 1 over u, I have to think backwards. What thing has a derivative of 1 over u? That would be the ln of x. And remember that it's kind of different because It's not just the ln of x, it's the ln of the absolute value of x. In this case, the ln of the absolute value of u. Kind of weird, but that's what it is. So it's minus ln, u in this case is 1 minus 2x, 1 minus 2 to the x. The ln of the absolute value of that over the ln of 2. So that would be my answer. Strange, but it works. All right, let's see. Again, if you need to pause the tape here, go ahead and pause the tape so you can get caught up and maybe talk to each other about this particular interval, because it's weird. Okay. Now, speaking of other bases, log base b of log, there's a change of base formula. Sometimes you can use that. Not really a fan of it because I just know the integrals, but you can always convert something to the different base by using the change of base formula. So if I have, like, for example, before I do that one, log base 3 of x, I can take the ln of x over the ln of 3, and then I can work with that if I'd rather work with that as opposed to doing intervals of logs of different bases. So, and you can't, I don't know. So if I convert log base x of 3 into a natural log, it would be the ln of the big number over the ln of the base. Okay? So if you want to convert things that way, you can. Sometimes it's necessary for different types of problems, but not usually. All right, the same can be said for exponentials. If y equals 2 to the x, we can always convert the base of an exponential to an e just by doing a little bit of math. This is really kind of awkward the way I wrote it. Take the log of both sides. Just to convince you. The x comes down out front there by log rules. Right? Okay. Now I take e to both sides. Okay, e to the ln y, these cancel, so you get y equals e to the ln 2 times x. So by multiplying, I convert 2 to the x to base e by multiplying by the ln of 2. All right, so that would be this and that are equivalent, which is kind of weird, but that's how it works. All right. Kind of mentioning that. Anything can be written as base C or ln, so that's why they use those, because those are common bases. They're bases they can use without all these weird ln's. Okay, for your mastery check, see if you can integrate that. You're going to let u be the inside, and this is going to be a little substitution. So I'm going to let you do that, and I'll come back tomorrow on my video. But today is really just review, so you're going to have time to work on your practice differentiating and integrating, making sure you know your formulas. At some point, we'll have a formula quiz over all our derivatives and integrals. Thanks. Are you telling me it didn't happen?